This is the video lesson for section 6.6, which is called Trapezoids and Kites. If you look at your objectives here, we've got 3 different objectives. The first one is that you can find angle measures in trapezoids, including isosceles trapezoids, which is a specific type of trapezoid, which we'll discuss on the next slide. The second objective is that you can use the midsegment of a trapezoid to determine requested values. So if you think about midsegment, we have talked about this word before, except we were using it in triangles. Now we're looking at midsegments of trapezoids. And then the last thing is that you can find angle measures in kites. So let's begin. The first thing we need to know is what a trapezoid is. So here I've drawn 2 different pictures for you. We have an isosceles trapezoid, and we have just like any typical trapezoid. Now, a few properties that all trapezoids have. One pair of parallel sides called bases. So I'm going to label these pictures here for you. This here, ooh, that's really hard to read. Let's try, wait. That there is called a base. This thing up here, though, at the top is also called a base, which is kind of counterintuitive because we think like bottom as base, but my 2 parallel sides are going to be my bases. So then in this picture, my 2 parallel sides I call bases. Base, base. The next thing that we have is we have one pair of non-parallel sides called legs. Let's see if red will work. So this here is a leg. This here is a, leg. And we've got 2 legs on this picture to the right. So there we've labeled all of our bases and all of our legs. And then the very last thing we have is we have 2 pairs of base angles. So let's label all of our angles. These angles would be a pair of base angles, and these angles at the top would be a pair of base angles. So these would be base angles, and the ones at the bottom would be base angles. So our first theorem here is Theorem 619, which says if the quadrilateral is an isosceles trapezoid, then the base angles are congruent. So we need to discuss what makes an isosceles trapezoid important. What makes it unique? What tells you it's an isosceles trapezoid? Well, think about an isosceles triangle. That's a triangle with 2 sides being congruent. So an isosceles trapezoid means that my legs are congruent. So if I look at the picture here, they show you have a tick mark here, you have a tick mark here. That tells you that your trapezoid is an isosceles trapezoid. Then the base angles are congruent. So this angle at the top R is congruent to this angle at the top A. This angle at the bottom T is congruent to this angle at the bottom P. And then we've also got Theorem 620, Theorem 620, which is also talking about an isosceles trapezoid, but now this time it says if you have an isosceles trapezoid, then its diagonals are congruent. So if I have an isosceles trapezoid, which they have given me, and I know that by these 2 tick marks here, which tell me my legs are congruent, then I know the diagonal from A to C must be equal to the length of the diagonal from B to D. So in an isosceles trapezoid, I know 2 things. Base angles are congruent, so T and P, R and A, and diagonals are congruent, so CA congruent to BD. So the next vocab word we have is midsegment of a trapezoid. Midsegment of a trapezoid. Okay. We've talked about midsegment of a triangle. This is going to be very, very similar. This is the segment created by connecting the midpoints of the 2 non-parallel sides of a trapezoid. Well, the 2 non-parallel sides of a trapezoid are also called the legs. So if I find the midpoint of each of these legs and I connect them with a straight line, that is called my midsegment. So all I have done is I have found the midpoint of each of those sides, and then I connected it with a straight line, and that is called the midsegment of my trapezoid. Now we happen to know a couple of things about the midsegment of a trapezoid. If the quadrilateral is a trapezoid, by Theorem 621, then the midsegment is parallel to the bases, and the length of the midsegment is equal to 1/2 times base 1 plus base 2. Okay, this is important to have. The midsegment is parallel to the bases. You also should have number 2 in your notes. However, when we use algebra, it is easier to think this thing right here. 2 times your midsegment is equal to base 1 plus base 2. This is going to be so helpful for us. 2 times your midsegment is equal to base 1 plus base 2. When we are going through algebra problems, that's more useful to us because then we don't have to deal with fractions. All right, so our first example, I have this trapezoid drawn for me, and they tell me that QR is the midsegment. So this thing is my midsegment, which tells me 2 things. 1, this QR is parallel to LM and PN. But that doesn't help me find my value of x. What helps me to find my value of x is that special relationship, which remember we just wrote down is 2 times the midsegment equals base 1 plus base 2. So let's write this out. I've got 2 times my midsegment, so 2 times x plus 2 equals base 1, I'm going to say is 4x minus 10, plus base 2, which is 8. So I took 2 times my x plus 2, and then I set it equal to 4x minus 10 plus 8. Now I go through and I'm going to simplify this. First thing I have to do is I have to distribute my 2 into those parentheses. So I get 2x plus 4 equals 4x, a negative 10 plus an 8 is a negative 2. And now I'm going to move my 2x, I add my 2 to both sides. And then I divide out my 2, and I get x equals 3. So x equals 3 is my answer to this problem. All they wanted to do is find the value of x. So that is what I've done. Now sometimes, aka in your next example, they want to know what is x and what is the length of one of the segments. So remember, you have to take that x and plug it back in order to find that length. So this next slide is asking us what a kite is. We've just gone through and done trapezoids, and now we're moving on to kites. So a kite is always going to have the specific property that the consecutive sides are congruent. So if I'm looking at this first example, these 2 sides are congruent. Also, these 2 sides are congruent. Notice that they're not opposite each other, they're directly next to each other. So in this second example, congruent, congruent, and congruent, congruent. I have 2 different sets of congruent sides. There's 1 there, and then 2 there. I'm always going to have my sides that are next to each other being congruent. And then the theorem that we know about kites is if a quadrilateral is a kite, then its diagonals are perpendicular. Diagonals are perpendicular if you have a kite. That's very important. So if I have a kite, I know my diagonals are perpendicular, which means intersect at 90-degree angles. So I'm going to have my diagonals intersecting at 90-degree angles. So just like right here in the middle, I see a 90-degree right angle box. So now when I apply this to a problem, my first example says, okay, I've got quadrilateral DEFG. They tell me it is a kite. So I know, because of that theorem we just learned, that my diagonals are going to intersect at 90 degrees. I have to try to find the measures of angle 1, 2, and 3. Well, measure of angle 1 is really easy. Measure of angle 1 is 90 degrees because that's my right angle box that has to happen where my diagonals intersect. Now if I look at angle 2, I have a triangle. So I'm going to use that triangle. I'm going to add up 90 plus my 52. I get 142, and then I need to subtract that from 180, which gives me 38 degrees. So I know the measure of angle 2 is 38 degrees. Now, in order to find my last angle, I have to think of something a little bit different. Now, I'm going to tell you this rule, and then I'm going to briefly prove it to you. If you want me to give you more proof, I can do that in class for sure. But I'm going to go through it kind of quickly here. I know that in a kite, when I have this diagonal here, I know I'm going to have this angle congruent to this angle and this angle congruent to this angle. So this diagonal has bisected my kite. If you look at this angle, or I'm sorry, this diagonal here, these angles don't necessarily look like they've been bisected, and they haven't, okay? But if I'm looking at this one, what's happened here is I've formed two congruent triangles. These two triangles are congruent triangles, and I can prove that to you by saying it's a right triangle, okay? Angle 1's a right angle. My hypotenuses are congruent because they are consecutive sides, and I know that in any kite I have consecutive sides being congruent. And they have this reflexive side in the middle here, which means these triangles are congruent by hypotenuse, leg. Hypotenuse, leg. Okay, so that's kind of obvious. They look the same. They are congruent. Clearly, this triangle is not congruent to this triangle, which means that this angle has not been bisected. But this triangle is congruent to this triangle, which means this angle up here, D, has been bisected. Long and short of it, if this angle here is 52, then angle 3 is also 52. So the measure of angle 3 is 52 degrees. So please, when you're doing that, just make sure you pick the two correct triangles that are congruent. Okay, so you're looking at your U-try problem down here. Please make sure that you're looking for your congruent triangles. That's all. I will see you in class tomorrow. Please make sure you have your notes ready to go and your U-try problems complete. Have a great night.